Hello everyone, in this video I will deal with the Tellegen's theorem. This is one of the most powerful theorems in network theory and we will say it's a statement. So it states that sum of power in a circuit at any instant is equal to 0. So, power, it can be written as voltage into current, right? So, summation of Pk, okay, that is K is equal to 1 to N, that is equal to 0. So, N is nothing but it is number of branches here, number of branches in the circuit. And here P is your power, right? So, suppose I have 4 branches, that means I can write P1 plus P2 plus P3 plus P4, that should be equal to 0. So, power, we know that we also write it as voltage into current. So, we can also write this as K is equal to 1 to N, Vk, Ik, that should be equal to 0. Okay, for DC circuits, this is the important formula where the summation of voltage and current and where we are taking the branches that is 1 to N, all the branches will be considered in a network. Okay, that summation should be equal to 0. So, from this we can also say that summation of power absorbed that is equal to summation of power delivered. When there are active elements in a circuit, suppose you have a voltage source or a current source, that they have capability of delivering the energy. So, it will deliver some power. And resistors, these are the passive elements, okay? So, they can absorb the energy. Resistors can never deliver energy. They always absorb energy, right? So, if I have only voltage and a resistor like this, okay, this is 20 volt I have, this is 1 ohm resistor. Okay, so what will be the current in the circuit? The current in the circuit will be 20 amperes, right? So, what is the power delivered? We can say that this voltage source is delivering the power. See, I have already told about the conventions in one of my videos and I will provide that link in the description. So, if you don't know that, please go and watch it. So, see here, if you have voltage source like this, and if the current is leaving the positive terminal, then the power will be absorbed. Okay, and you have a voltage source, but if the current is entering the positive terminal, then power will be delivered. Okay, remember, if this is minus 2 ampere which is entering, then obviously that will be a leaving current. Okay, I is equal to 2 ampere. Okay, you have to see the signs also. Then if you have a current source like this and if the voltage across this is like this, that means we can see the current is leaving the positive. That means here we have power delivered. And here we have a current source. Suppose we have the polarity across the current source like this. So in that case, what happens? Current will be entering the positive terminal. That means power is absorbed. Okay, so likewise if I take this, what happens? This is the current 20 ampere, this is the voltage 20 voltage. So power is equal to V into I, which is 20 into 20, which is nothing but 400 watts. Okay, 400 watts is delivered now. This is the power delivered. Now we know that resistor, it only absorbs power. So here there is 20 and this is 1. So power I can write it as I square into R. So again it is 400 watts. So this is the absorbed power. So what happened? 400 watt is delivered, 400 watts is absorbed. So this condition satisfies, right? Power delivered is equal to power absorbed in the circuit. This is satisfied in this particular case. So, in whichever circuit you consider, okay, you will be having this expression and you will see that this expression will be satisfied in any particular circuit. Okay, in any circuit you can apply this concept and you will see that the summation of power delivered will be equal to summation of power absorbed. Tellegen theorem, it is applicable to linear circuit and also non-linear circuit. Okay, non-linear circuit means the circuits that consists of diodes and transistors. You know about linear circuits. It is applicable to time varying and time invariant. Time varying and time invariant circuits. It is applicable to AC and DC. It is applicable to AC and DC. It is applicable to active and passive networks. Okay, so it is, and main thing you must remember is it is applicable to the lumped network. So in network theory we will be dealing with the lumped networks, right, where the resistors, inductors, capacitors which are in the circuit, okay, they can be removed separately, means they are physically separable. They are, okay, like this. If you have something like this, okay, so this is a lumped network, right? This is a lumped network. But for example of distributed will be your transmission line, where the resistance, inductance, capacitance, these all are distributed throughout the line and they cannot be separated. That means those resistance, inductance, capacitance, they are not physically separable in case of transmission line. But here they are physically separable and they are called as lumped networks. So Tellegen's theorem is applicable to only lumped network. Okay. So we saw the formula, that is summation of Vk Ik, k is equal to 1 to n is equal to 0. So what is your n? I said n is number of branches. N is number of branches. Then what is Vk? It is the voltage across kth branch. Voltage across kth branch. What is Ik? It is a current in kth branch. Suppose we are considering the AC circuits. Okay, in that case this formula becomes k is equal to 1 to n Vk Ik conjugate, that is equal to 0. We will be considering the complex power, right? So summation of the complex powers, that will be equal to 0. And what will be this Vk? It will be your phasor voltage. It will be your phasor voltage. And what will be Ik? Ik is nothing but, Ik will be your phasor current, and this is the complex conjugate of phasor current. Complex conjugate of phasor current. So please remember this in case of Tellegen's theorem. Now let us consider a circuit here. Okay, what I will consider? This as 2 amperes. I will consider a resistor of 1 ohm. Okay, we will have the voltage across this, that is plus or minus V, which is not known to us. Okay, and here I will take 2 volts source. Okay, 2 volt source like this. So now we have to see, this is the mentioned one. Now we have to see what is the power delivered or absorbed by this current source. And another one important point is, your independent sources like current source or the voltage source, okay, not only they deliver power, but sometimes they can absorb power also. Okay, they can absorb power also. So here we can see this is the 2 ampere current which is flowing. So that means we have 2 volts here. So if I take the KVL in this case, V, then I have minus 2, then this is plus 2 equal to 0. That means V is equal to 0. And we know that power is equal to voltage into current. That means it is 0 watts, right? Because voltage is 0. It is 0 watts. That means it will neither absorb power nor deliver power. Which one? This current source. Okay. It neither absorbs nor delivers power. Sometimes in few cases what happens is, you will be having a voltage source. Here there will be some specified value for this. Suppose I have this 10 volts. But what happens is the current through this will be equal to 0 amperes. Okay. In few problems you may get this also, where it will be 0 amperes. In this case also we can say that the voltage source is neither absorbing power nor delivering power. Okay. We will consider a simple circuit and we will see whether each element it delivers power or absorbs power. Okay, and one important point is when applying this Tellegen's theorem, do not alter the circuit. Means whatever original circuit they have given, please keep that as it is. Okay, do not do any modification here. No modification. That means you cannot apply source transformation theorem also. Cannot apply source transformation. No modification of the circuit. Okay, so let us take one circuit here. This is 2 volts I will consider. This is 1 ohm resistor. Here we have 2 ohms resistor. Here we have 3 ohms resistor. And here let us take another source that is of 5 volts. Okay, so this is a simple circuit. We will see what is the power delivered or power absorbed in this case. So in this case, I will apply the nodal analysis. I will take this voltage as V. I will take random currents. Okay. So in this case, I can, all the currents are outgoing. So at that particular node voltage V. So what I will do is V minus 2 divided by 1 plus V divided by 2 plus V minus 5 divided by 3, that is equal to 0. So if I take the LCM, that will be 6. And here it is 6V minus 12. Plus 3V plus 2V minus 10, that is equal to 0. So if this denominator goes that side, that will be equal to 0. So I am removing it. 6V plus 3V, 9V. 9V plus 2V, it is 11V. 11V, and this one you can see it is 22, right? 22. So that goes 11V and here 22. So voltage will be equal to 2 volts. Okay. So this is your 2 volts. Okay. This is 2 volts now. That means, what about this current? That will be 2 minus 2 divided by 1. See, this is 0. 2 divided by 2, this is 1 ampere. See, 2 and minus 5, that is minus 3. 2 minus 5 minus 3, that is minus 1. If it is minus 1 in this direction, that means it is 1 ampere flowing in this direction. See, whatever I said, that time I gave you an example where you have a voltage source, but what happens? The current, okay, that is coming out of that voltage source, that is equal to 0. See, we saw that here. Okay, that means here what happened? Current is 0, voltage is 2. That means power is equal to 0. That means this voltage source is neither delivering power nor absorbing power. And here it is 0. Again, there is nothing here. Power is 0. But here we can see it is 1 ampere and 2 ohm. So power of 2 ohm, that is equal to I square into R, that is 2 watts. Next we have 3 ohm. Power of 3 ohm, that will be equal to I square into 3, that is 3 watts. And next we have power of this voltage source. You can see that the current is flowing in this direction. That means current is leaving the positive terminal. So it is delivering the power. That is delivering the power. So PV into I. So 1 into 5 is equal to 5 watts. And resistors always absorb power. So this one will be your absorbed power. If you take the sum, it is 5. So power delivered is 5. Power absorbed is 5. 5 watt is equal to 5 watts, right? So condition is satisfied. The summation of power delivered is equal to summation of power absorbed. Okay, the Tellegen's theorem is verified. And we also saw the case where the voltage source is not delivering or not absorbing any power. Okay, because this is equal to 0 watts. It is neither delivered nor absorbed. So this is the Tellegen's theorem. This is how we are going to apply this. Okay, no modification is done to the original circuit. We are not applying any kind of source transformations, nothing. We are not going to do any simplification. Just if this is the case, apply nodal analysis, find the currents in each of the branches. Okay, find the current in branches, find the voltages, and from that you can easily find out the power delivered or absorbed by the elements. Okay, and another thing is this Tellegen's theorem, it is based on KVL and KCL. You saw it, right? Here we saw that all are outgoing currents. So KCL is mainly for currents, and we can also apply the mesh analysis. Okay, we can also apply KVL also. Okay, so it is based on the KVL and the KCL. And one more thing, you know that if the element is delivering 10 watt power, if it is delivering, that means it is absorbing minus 10 watt. Okay, power delivered, that is equal to minus. If you attach minus or reverse the sign, you will be getting the opposite one. If it is absorbing positive power, if it is absorbing 20 watts, that means it is delivering minus 20 watts. It's something like this. Okay, this all I have covered in my video. You can go and check it also. Okay, so this is all about the Tellegen's theorem.